This video will cover the setup, acquisition, and processing of the HSQC experiment. The HSQC is a heteronuclear 2D experiment which basically shows which carbons and hydrogens are directly bonded to one another. To set up the HSQC, we can go to the Start tab and click Create, and then select a parameter set. If you have a long list, you can check the box Show Recommended. And then we're going to select the HSQC EDET GPSISP. We'll use that parameter set. We click OK. And then update the title to reflect the fact that this is the HSQC. And we can go to the Acquisition Parameters tab to look at the parameters that we have set. We'll change the number of dummy scans, reduce it from 32 to 16 to shorten the time for the acquisition. And we can check the time for this by going to the little clock icon and clicking on it. We can see here the experiment will take about 30 minutes. The default spectral window for the proton is around 13 ppm and 165 ppm for the carbon. We can adjust that by going to the Set Limits button, and then we can open the proton spectrum and zoom in on the region that we actually have peaks. We can see here it runs from about 5.5 to 1 ppm. We'll go about 1 ppm above and below that region, click and drag to expand that section, and then click OK. And you'll see the updated spectral width and the offset. And then we can repeat that again for the carbon spectrum. You'll note in the carbon spectrum we do have a peak out around 165 or 170. That is a carbonyl, does not have hydrogens on it, so we will zoom in on the region of the protonated carbons. So we'll go from now 10 above and below, so from about 100 to 0 ppm. And again, when we click OK, it will show us the new spectral region that we're looking at. The Acquisition tab, we can see here that the spectral window has been updated as well as the offset, so that we are now set up for to acquire just in the regions where we have peaks for the proton and for the carbon. This sample is already tuned and shimmed, so we can go to ProSol, and then we will set our gain and click Go to actually acquire the spectrum. We won't bother watching the entire acquisition. The video will jump toward the end after we've finished the data collection. But if you zoom to the bottom of the screen there, you can see we have a residual time for about 34 minutes, so a little more than half hour for this experiment to acquire. The acquisition is now complete, so we will process the spectrum using the Process Spectrum button in the Process tab. We'll adjust the threshold using the scroll wheel on the mouse to eliminate the noise or peaks that don't correlate with peaks in the 1D spectra. And then we can expand the region that has the peaks, eliminate the white space surrounding the spectrum. For the one-dimensional spectra, I prefer the carbon to be rendered as the depth, so we can right-click on that carbon spectrum, and from the pull-down menu, select the external projection, and then pick the depth 135, which in my case is in experiment number 3. Also prefer the depth to be centered, and so we can right-click and put baseline at center. Now we can clearly see the CH2 peaks in that depth spectrum. I'm going to zoom in on this region with the uh, multiple carbon peaks that are very close to one another. And you can see from the expansion that we do have enough resolution. We can make the assignments, the 2D peaks of specific carbon peaks, although there is a little bit of ambiguity there. We could minimize that using non-uniform sampling, which I talked about with the COSY video, and also use something called band selective detection, which I will cover in a future video. Band selective detection, we will look at just the region of interest.